Tips on Proofwriting Part 3. Doing a problem from page 82, number 25. We've worked with parallel lines, but in this problem there's a little bit more complication going on. We have all these angles in the drawing, and we only have two givens, and it appears that this is going to be a more complicated proof because you can't necessarily see what is true based off of the drawing. Now this is where it's helpful to have more than two colors, because what I'm going to do is in the green pen on the drawing I'm going to mark what is given, and then in blue in red I'm going to write what I have to conclude in order to prove that it's true. So since we want SA to bisect this angle, we need angle 1 and angle 2 to be congruent. So I'm going to write a little reminder that I need to first conclude angle 1 and angle 2 is congruent, and after I prove that, then I'll be able to prove that this ray bisects this angle. Now notice what happens. I wrote in the green, I wrote in the red, and I thought I might have had to prove something else, but just looking at it here, look, we have 4 is congruent to 5. Because of the parallel lines, 5 is congruent to 2, and 4 is congruent to 1, and so then therefore by transitive, angle 1 is going to be congruent to 2. Now writing those few notes helps me to go through a brief process of what I need to go to. Now it was pretty easy to order it, but remember that I kind of started at the end here in order to get an understanding, and it really helped to use the colored pen, the red, to see the connection between the given, the green. I'm ready to write my proof. Starting with the given. AS is parallel to BT. Now, since I already know where I need to go, and I know that I need 5 equal to 2 and 4 equal to 1, or I should say 5 congruent to 2, 4 congruent to 1, I'm going to go ahead and make my conclusions based off of this given. Angle 5 congruent to angle 2. And that is because if two parallel lines are cut by a transversal, then alternate interior angles are congruent. Now, even though we're using the same parallel lines to prove that angle 4 is congruent to angle 1, angle 4 and angle 1 are corresponding angles, whereas angle 2 and angle 5 were alternate interior angles. So it's a different theorem, therefore I'm going to have to write it as a different step. It's a different reason. If two parallel lines are cut by a transversal, I'm going to go ahead and use abbreviations since you are familiar with this one, then alternate interior angles are congruent. Finally, I need to write down the other given that will help me connect all of these angles. And that given is angle 4 is congruent to angle 5. And now we have the last step, what we have to prove that not the last step, but the second to last step of what we have to prove, that angle 1 is congruent to angle 2 by the transitive property. And finally, we know by the definition of bisector that SA bisects angle BSR. Okay, so a bisector bisects an angle into two congruent parts, but you also know that you have a bisector if you have two congruent adjacent angles, like we have here of 1 and 2. A note about the transitive. In the previous part, I was using the substitution and transitive property interchangeably. In this case, you cannot. You can't say substitution because there is no substitution property of congruency. This is congruency. This is congruency because you're starting with congruent objects that are congruent to each other. You don't have any equality given. Therefore, you can't use the equality, the substitution.